Hello everyone, it's Michael back from the dead. I've been getting a lot of these comments about me continuing to do this UIL CS stuff over the last couple of years, before, during, and after COVID, I guess. I had a comment recently from someone named Angel to do a modern revision or modern version of this. Not sure if I'll do that, but maybe I will. We'll see how this video goes, I guess. I searched up UILCS on Google to see, if anything I change, due to AI and stuff. But I guess not. Things look the same. And then I came across this link which showed the 2024 last year's state exam. Took it yesterday. It was really easy. So I just wanted to show everyone, I guess, how easy it is. And, these exams aren't as difficult as it may seem. Basically, the strat or the meta is to first understand the question. First read the question. And then after you read the question, ask yourself, what does it want me to do? And then once you know that, you can solve it. Want me to do. It's pretty straightforward. So I'm just gonna do it my way, how I would do it. I'm not gonna go too much into detail on lecture on how to really do it, but just my way and see how it goes. Okay, enough yapping. I feel like I'm just talking too much. Okay. Number one, we want to find out which has the most ones in its binary representation. So we see that the bases are 8, 16, 4, 8 again. These bases are powers of 2. So this is 2 to the third. This is 2 to the second, 2 to the fourth, 2 to the third again, right? And if you looked at my previous videos, you know that each digit, for 8, would represent 3 digits in binary. So this goes, here, and then another 3 digits for this 4 and so forth. Let me erase this. So let's just figure it out. Let's convert them all to base. We don't have to convert to base 2 actually. There's a much faster way of doing that. But so 63. 63 is 1 less than the power of 2. It's 64 minus 1. It's a Mersenne prime. Right. It's going to be 2 to the 6th power minus 1. So we know this is going to have 6 ones. So I'll just write a 6. If you don't know, you can double check. It's kind of like how 3 is a Mersenne prime, right? It's 2 to the 2nd power minus 1. So it's going to have 2 ones in binary. 2 to the 8th power, 2 to the 3rd power minus 1 is 8 minus 1, which is 7, which is 3 ones in binary, and so forth. So if you recognize that it's 1 less than the power of 2, then it's going to be full of ones in binary. So here's 6. Now for the rest of these, I'm just going to put the number of ones in each digit, and then I'll just add them up in the end. So here for 8, 4 to be in binary is going to be 0, 1, 0 for 8, because remember it's 3. So 3 digits right here, right? And sorry, not 0, 1, 0, 1, 0, 0, 1, 2, 4, right? So it's 1, 0, 0. So all these are 4, which means this is going to have 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, right? So how many of these are total? 6 also in total. Look over here. Same thing. 2 is going to be 1. 3 is going to be 2. 1 is going to be 1. 2 is going to be 1. 3 is going to be 2. So that's going to be 4, 6, 7. 7 right here. Right, are you following me? 16, right? It's going to be 4 digits. How do you get A? Well, A is the number 10. So 10 is going to be 8 and 2, right? 8 plus 2 is 10. So it's going to be 2, 2, 2. So we get 6 again. And then we go here, 8. So to get 4 is 1. To get 5 is 4 plus 1. So it's going to be a 2, sorry. 6 is 2 and 4, which is 2 again. And 7 is going to be, well, 7's a Mersenne prime, right? It's going to be 3. It's going to be 1, 1, 1. So we add this up, we get 8. So the answer is A. Sorry, did I do this wrong? Oh no, am I going to do this all over again? 1, 2, 3, 4, 5. So, wait, I'm looking at the wrong exam. Haha. The answer is A, yes. Okay, sorry about that. I had the wrong exam out for the answer key. Okay, let's keep grinding. So here, these all have the same precedence, so we can just keep going straight to right. Multiplication and division. So 22 mod 30 is just going to be 22, right? Because 22 doesn't go over 30, so 22 is the remainder. Now remember, they all have the same precedence, so we keep going. 22 times 4, that's going to be 88. So cross this out, we get 88. 88 divided by 10. Well, 88 is an integer and 10 is an integer too, so we're going to get 8.8, but we truncate, so it's just going to be 8. So the answer is B. This one's A. Okay, next one, C. Okay, we have two strings and then we're going to add them. So when you add them, you concatenate them, which means, you know, this is going to go like right. Oops. It's going to go right over here, right? We want the substring from 10 to 15. So alpha's first, so we just count. We're going to start at 10 and we're going to end at 15, but we're not going to include it. So actually we're going to stop at 14. So let's find out what that is. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 starts at K. 10, 11, 12, 13, 14. Now we want the substring starting from 3. So from 3 on, so 0, 1, 2, 3. So 3 on is no. So the answer is D again. Next one. Okay, so for OR, as long as one of them is true, the answer is going to be true. So since A is true, this one's true. For AND, both have to be true to be true. So A is true, which is fine, but B is true and not B is false. So the answer, this one's false, right? And what's exclusive OR? Exclusive OR means they have to be opposites. So B and C, they're opposites, which means it's going to be true. So the answer is A, 4 is A. Next, 5. So multiplication division has higher precedence than plus. So 20 times 30 is 600. 600 divided by 40 is just going to be 60 divided by 4, which is going to be 15. Plus 10 is 25, right? And then this one's going to be 600 divided by 10, which is 60 plus 40, which is 100, right? So now we have T plus R, and then this is right shift 2. Right shift has lower precedence than plus sign, so we are going to actually add T and R first. So 25 plus 100 is 125, and we're going to right shift it 2. Right shifting 2 just means, you know, moving the bits in binary twice to the right, which effectively means we're going to divide it by 2 however many times it is in here. So we're going to divide this number 125 by 2 twice, or you know, you can do 2 to the second power, which is 4. So we're actually going to divide by 4, but I like to keep dividing by 2 because it's simpler that way. So 125 divided by 2 is just going to be 62 and some change, but we don't care about the change, so we're going to get 62, and then divided by 2 again is 31, so the answer is C. This one, so square root, A times B times C times C times C. Okay, well, square root of 10 is square root of 2 times square root of 5. So C is square root of 2, and we see that is going to be 4 times 1, 2, 3, and 4 from A. So that's just going to evaluate to 4 times B, which is square root of 5, times the square root of 5 left over, which is 5. So the answer is 20. That was an easy problem. Or you could just straight up multiply. This one's what? You can get like 400, square root of 400, which is 20. Whatever. Let's go to 7. This one may look tricky, but it's actually not. So notice how there's no brackets. Usually you got brackets after an if statement. In this case, there isn't. You can make single line if statements, and all it means is that whatever is immediately right after the if statement is like tied. So these are tied to each other. But these guys right here are going to happen anyway because they're not tied to the if statement. They're just on the same line in the code, but they're going to happen anyway. So let's see. Is 11 greater than 12? No, it's not. So B is going to be 9. And then is 11 greater than 9? Yes. So we're going to add 1 to B and subtract 1 from C. Then is B greater than C? Is 10 greater than 11? No. We're going to subtract 1 from A. So now A is going to equal 10. And then is 11 greater than 10? Yes. So we're going to add 1 to A. So A is going to equal 11. We're going to subtract 1 from B. B is going to equal 9. And then is B greater than A? Is 9 greater than A? No. So we're going to subtract 1 from C. C is going to be 10. And then is C greater than A? So it's 10 greater than 11? No. So we're going to subtract 1 from A. A is going to equal to 10. So we're going to get 10, 9, 10. So E. Okay, very simple. Okay, so C is going to be numbers of 1, 0 indexed. If you want, we can, do this. I don't really do it, but, for more visualization. Numbers of 1 is going to be 6, right? D is going to equal C, so this is going to be equal to 6. X equals numbers of 4, which is 3. And X is less than D, which is 6. We're going to add numbers of X to C. So it's going to be 6 plus. So the first round, numbers of 3 is going to be 5. Plus, this becomes 4. So what's numbers of 4? Yes, what's numbers of 4 is 3. And then this becomes 5. What's numbers of 5? 0. And then you get to 6, but you don't count 6. So it's just 6 plus 5 plus 3, which is what? 14. 8 is B. Yep. Easy. Okay, so for loop 1, 2, 3. So it's gonna run 3 times. We get the length of the string, and then we're gonna get the substring from 1 all the way to the length of the string minus 1. But remember, this last one doesn't count, so we're actually gonna count the one before whatever this one ends at. But pretty straightforward. T is the length, so we're going to go all the way up to the one before it, which is I. If T was the last one, we'd include the J, but because we subtract 1, we go to I. All right, does that make sense? T minus 1, we don't include it. This is the index at T minus 1, we don't include it. Yep. And then we just do the same thing for all of them. So we don't include, we start the second and we don't include the last. So it's going to be D, E, F, G, minus C. Yep. Sorry, excuse me if I'm not really explaining well, but once you're able to read it, you understand what it's trying to ask you, then you can just keep doing it. Here, int A, capital A, the ASCII value is like 65, and then for lowercase a, it's 97. They're 32 apart from each other, which is a key number, which is important. So you just subtract them, 97 and 65, right? What do you get? 2, 3, 32, negative 32. Right, they're 32 apart, so it's just gonna be negative of them. Easy. This one is a ternary operator. It's an if statement, basically, just very elegant and simplified. I use this all the time in my job. So we just look, is A less than B, is 4 less than 7? Yes, so we're gonna get so. And then is C less than B, is 8 less than 7? No, so we're gonna get hungry. So we look at them, no new line, so, and then space, and then hungry space. So space, hungry space, which is E. So easy. This one, very simple logic. Just convert them into binary and then do the logic there. So I'll do the binary stuff to make it simpler for you guys. We can do 32, but we don't need it. Okay, so 16 could go into 30 one time. You left with 14. How do you get 14? 8 and 4 is 12 plus 2 again, right? And then how do you get 29? Well, 16 goes into 29 one time. You get 13. How do you get 13? 12, so 8 and 4 and 1 here. Now you want to take the and of them, right? So ampersand. And yeah, just go down. They both have to be true. So 1, 1, 1, and then you get 0, 0. Easy. And then, so that's A. A is 1, 1, 1, 0, 0. And then what is B? Well, we know 29 already is this last one. So, my thing is too big. But 29 was this one, I believe. 16, 8, 4, 2. And then how do you get 28? Well, 28 is 16, and then you get 12. How do you get 12? 8 and 4, and then 0, 0, right? So they both need to be true, so you get the same number. It's going to be 29. The answer is C. 12 is C. Oh, sorry. 16 plus 12 is 28, sorry, B. Again, this becomes 28. This becomes 1, 1, 1, 0, 0, right? And you OR them. With OR, you only need one true to be true. So this is going to be the same number. So 16, 8, and 4 is 16 plus 12, which is 28. So the answer is 28. So get this one. Okay, well, when we do remainder 10, we always get the ones digit. So it's going to be 8. Now divided by 100. Remember, 100 is an integer and A is an integer, so there's going to be truncation. So we don't care about the last two digits, so it's going to be 1, 2, 3, 4, 5, 6. Now we're going to take C, multiply by 10, so take the units digit, 6, and divided by 100, so forget the last two digits, 1, 2, 3, 4. Same thing, it's going to be 4, and then divided by 100 is going to be 12. And now we want to do B, D, F, G, so 8 and 6, 4 and 12. So 10 and 20 is 30. So the answer is A. Easy. Okay. So x is 100. While x is greater than 75, I want to subtract it by 6. So just multiples of 6, really. What's the biggest multiple that can fit before 75? It's 24, right? 100 minus 24 is 76. But 76 is greater than 75, so we want to subtract it again, and then we get 70. So right now we're going to be left with 70 for x. Now while x is less than 90, we're going to keep adding 4. Well, 70 and 90 are both 20 apart, and 20 is a multiple of 4. So we're going to get to a point where we're going to get like, is like 86. Less than 90, yes. Out of 4, we get 90. Is 90 less than 90? No, so we stop there. So we're going to get 90. And then, while x is greater than 40, keep subtracting 10. So we subtract 10 all the way until we get 40. Is 40 less than 40? No, so you stop doing that. So what is x? X is going to be 40, so whatever that is. C. Next. Okay, so this is for each loop. Use these often as well. basically means like for each element or for every element. So we're going to take the element and then have that as x. And then same thing here for each element in B, have that be like have that integer in this case be y. And now we're just looking to see if the tens and on match each other. So we just look at the tens digit. We can divide all of them by 10. It'll be easier if we do it this way. So 0, 0, 1, 1, 10, 10, 11. And this is going to be 2, 2, 2. This is going to be 1, 1, 1, 0, 0, 0. Again, with integer division, you get truncation. So 111 divided by 10 is 11.1, but we don't care about the decimal. So we just get 11, right? And now basically just asking, hey, if we get a match, add it to the counter. So we take this first 0 here. Okay, so this first 0 here. How many zeros do we see in the second one? Well, we see 3. So 3. And then we go to the next one. How many zeros do we see in the second row? 3 again. 1. How many ones did we see? 3. 1. How many ones did we see here? 3. And then we go 10. How many 10s do we see? 0. Same thing here. 10, 0. What about 11? We didn't see any 11s. So it's just 3 plus 3 plus 3 plus 3, which is 12. So the answer is 12. Okay. So here we see we're creating 3 strings. One is UIL, the other one's UIL, and the other one's Texas. This is just a fancy way of saying, just like UIL. Now, whenever you want to compare strings, you should never use A equals B because they both aren't referencing like the same object. I think that's what it is. But if you want to see like the content equals each other, you would use this one, the dot equals method. So we know that all of these are going to be false. So, we don't really care about any of these. Does A equal C? No. But does A equal B? Yes. So C is just going to be 1. So the answer is A. Very easy. Remember, if you want to compare strings, use the dot equals. This one, we get formatting. Point to F just means, formatted 2 decimals, 2 places after the decimal. So 2, 3, but there's a 7, so it's actually going to be 20.24. A is the float, right? The floating point. There's no new line, so it's going to be 20.24, and then we're going to print university, right next to it. So university, whatever that is. I don't want to do it all with the space, and then of Texas. And then there's a new line, so we're going to create a new line, and then we go interscholastic, and then no new line, so we go here, league. Sorry, I just don't want to write it all. So, which one matches what I see? It's going to be D. Yeah, D. Yeah, I guess if you're trying to speed run through the test, you kind of see, 2024, okay, university right next to it. Which one doesn't have that? All of them except for D, so, you could just do that. You gotta go through all of it. Tree set, don't really know what it is, honestly, but I do know that it's just an ordered set with no duplicates. So we have a new tree set full of integers, so we're gonna go through 1 through 20, and we're just going to add it to our set. So right now our set's going to contain 1 through 20. Now we're going to do another loop. Now we're going to go from 15 to 35. We're going to add it to our set, but there's some overlap. So it's actually going to be 1 through 35. No duplicates. And then here we're going to go from -12 to 8. And there's overlap from 1 through 8, right? So it's actually going to be from -12 all the way to 35. And now we'll go here, C equals 0. So for every integer in this tree set, that's going to be equal to Bob, right? Now we want to print C mod 10. Well, it's going to go through the entire set up until you get 35. So what's 35 mod 10? It's 5. So the answer is C. Oof. Oh, this test, I didn't realize how long it is. Okay. 2 octal string just turn into base 8, right? So 1, 8, right? And then we get 64. So 83 goes into 64 one time. And then you do 83 minus 64, which is 83 minus 64, what is that, like 19? Am I doing that right? 19, yeah, I guess so. 19, so 1, and then 2, and then 3, right? And then we want to take the substring 1 through 2. So we start at 1, and then we end at 2, but we don't include it, so it's just going to be 2. 19 is B. For which value of n will the code to the right print an odd number? This one seems tricky, but it's really not. So, 1 through n, these numbers are pretty long. Now look, it's if n mod x equals 0. So what does that mean? It's saying, well, if x is a multiple of n, then add 1 to c, right? Now we want it to print an odd number. So, you're basically adding up the total factors in a number. And if you want an odd number of factors, that number needs to be a perfect square. So the answer is E. Again, what is the question asking you? It's asking, okay, look, if n mod x equals 0, so is x a multiple of n? If it is, then we add 1 to the counter. So it's counting all multiples, right? Or all factors. Sorry, that's what I meant. Counting all factors. And if you want an odd number of factors, the number has to be perfect, right? It's kind of like symmetrical that way. So yeah, it's E. Okay, this one, 21, 22, 23. Okay, what's the mystery of 3? This is just simple recursion. We look, this is the base case to return the number divided by 2. So 3 is not greater than 10 or greater than 5, so we're going to return 3 divided by 2. Well, they're both integers, so truncation becomes 1. So the answer is A. Next one is 8. 8 is not greater than 10, so we go here. This is going to be equal to 2 plus m, which is 8, plus mystery of m minus 2, which is 6, plus m of 6. Well, what is m of 6? M of 6 goes here, and 6 is not greater than 10, but 6 is greater than 5. So we're going to do 2 plus 6 plus m of 4. We go m of 4, but what's m of 4? It doesn't pass any of these, so 4 divided by 2 is 2. And now we just add them up. So 4, 10, 20, 22, B, yep. Then let's erase this, get more space, because this one's a bigger number, 15. 15 is greater than 10. So, we have 3 plus 15 plus 15 minus 3 is 12. And then we go here again, because 12 is greater than 10. So 3 plus 12, and then we're going to go 9. 9 is not greater than 10, it's greater than 5. So 2 plus 9 plus, and then m of 7. So it's going to be 2 plus 7 plus m of 5. Well, 5 is not greater than 5, so what's 5 divided by 2? It's 2.5, which is just 2 because of truncation. And now we got to add all this up. This sucks. 2 plus 7 is 9, plus 9 is 18, 20, 22, 34, 37, 52, 55, 23. Okay. Array list, string array list. We have Hutch, Starsky dot add substring of x. Oh, I see. Okay, so you basically only add university, and then you're gonna go 1, and then 1 is over here on the n, so it's gonna be university. And then university, then verse, ity, then ity, then city, sity. I don't know if I should be doing all of this, but I'm already done. Right, because we start at 0 and we want to add the substring from 0 onward, so it's university, and then we go 1, so 1 onwards, 2 onwards, etc., etc. Okay, and now this is where we got to know rejects, but basically it's just asking, hey, does it start with the vowel? So we start at the first one, right? Because we start at 0. So is there a vowel in university? It's like, yeah. So I guess 0, 1, 2, 3, 4, 5, 6, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Haha, 10. Yeah, so this crosses out, and then x becomes 1. This becomes 1, but then all these get shifted, so this is actually going to be the new 0. So 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. So x equals 1, so let's go 1. Does 1 start, with the vowel? Yeah, so we cross that out. And then these get shifted, so it becomes 0, and then we skip this one. 1, 2, 3, 4, 5, 6, 7, and then 1 becomes 2. Then we look at 2, university, yes, and then we just look, okay, Starsky to get 2. Well, 2 is going to be 0, then 1, and then 2. So it's our city. So the answer is A. 24 is A. This one was a more complicated one, but if you just go through the logic, everything is just easy. Okay, look here, math.square root of n plus 1. So what's the square root of 625? It's 25 plus 1 is 26. And then we take the square root of that again. Square root of 26. Well, what's that going to be? That's going to be like, 5 and some change. So we're going to get 5. And what's the square root of 5? Square root of 5 is going to be like 2 and some change, which is going to be 2. So, I'm supposed to add 1. My bad. This is going to run 3 times, 1, 2, 3, right? Because x is less than or equal to 3. So, again, 25 plus 1 is 26. So, that's the first path. And then the second pass, what's the square root of 26? Well, that's going to be 5 and some change. So, 5, 6. Now, what's the square root of 6? 6 is going to be 2 and some change, but plus 1 is going to be 3. So, the answer is C, 25. Oh my god, it's probably going to be a bad video. I'm so boring. Maybe I just don't have any energy. But okay, let's see here. Okay, this seems intimidating, but it's really not. We have a state class. Here we have our constructor with a parameter. We have a constructor with no parameter. Then we have a get B method. Pretty simple. And then I guess we have some variables here as well. So regional extend state, district extend state. So let's look at this one. Andy is new state 55, right? So we go to the constructor with this one. So Bob is going to equal to B, right? So the first line is Andy dot get A. Well, Andy is states get A. What is states get A? Return apple. What is apple? 44, so that doesn't change. So D. Okay, let's look at this one. Bet dot get A. So regional, we go to regional. Dot get A is the get B method. Well, what's the get B method? Is return Bob, right? But there was no parameter in there. So what is Bob's? is 33. So the answer is C, 27, C. Okay, 28. Deb dot get A. So we have district. Look at district. Get A is the get A method. Nothing gets passed in. So get A is return apple. So we look at the constructor with no parameter. Apple is 22. So the answer is B. Easy, right, guys? Yes, no, maybe. So, oh, look. Yes, no, maybe. Maybe that's why I was saying it. Haha. Okay. So these are our array lists. So from 0 to 50, so we're going to add all multiples of 7. So 0, 7, and so forth. 14, dot, 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 dot. Okay. Now this one is going to be multiples of 5, but it says here if yes, if a multiple of 5 does not appear in this first one, then add it. So let's not add any of the multiples of 5. So we're gonna get like what, 5, and then we're gonna get 10, 15, 20, 25. We're not gonna include 35 because 35 is part of yes, right? And we're not gonna include 0 because 0 is part of yes as well. And then we look at here, so x plus 2 is gonna be multiples of 2, and we don't want any multiple of 2 to be included here or here. So no 0, so we have 2, 4, 6, 8, no 10, 12, no 14 because 14, blah blah blah. So all this wants to ask is what's the length of all of these? Well, the length of yes is going to be all the multiples of 7. So what's the highest multiple of 7 to go into 50 is 7, right? 7 times 7 is 49, but you got to include this an extra 1 for the 0, so it's going to be 8. So 29 is C. And then we look at 30. Again, we want no multiples from 0 to 50 that are also not multiples of 7. So we don't want 0 and 35. So 5 to 50 is 10, minus 2 is 8. Sorry. 0 to 50, so no 0 and 35. Sorry, yeah, it's 10 multiples of 5 go to 50, right? Because 5 times 10 is 50, but you got to add 1 because of the 0, but we don't want to include 0 and 35, so 11 minus 2 is 9, so the answer is 9. Sorry, I don't know why my mind blanked out on that one. And the last one, we don't want even numbers from 0 to 50 that are not multiples of 5 or multiples of 7. So, it'll be 25, 26 total. And then we just need to subtract numbers. So we don't want 0. We don't want 10, 14, 20, 28, 30, 40, 42, and 50. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 26 minus 9 is 17. So the answer is 17. Okay. This one looks really funky, but it's not funky because x is originally defined here, so that's fine. We have our condition established here, and we have our step counter in this last one, so it's actually very valid. Now we just look. If x divided by 10 equals 6, then we want the remainder. We want the ones digit. So let's look. X starts at 15. 15 divided by 10 is just going to be 1. Do we get 6? No, so we keep adding 3. So let's just look at the multiples of 3. That the tens digit is a 6. Well, that's going to be the 60s, right? So 60, 63, 66, 69, right? If 6 divided by 10 equals 6. Yes. And then what do we want to do? We want to mod 10 it. So 3, 6, and 9. 9 plus 9 is 18, which is B. This one. Our string is A. Okay, we're gonna keep adding 4. So this means, you know, st plus, and then whatever this is. So what is st? It's A first. Now we're gonna add an empty string, and then we're gonna add whatever this evaluates to. So the character at 0, because c is 0, is A, and then we're gonna add 4 to it. I mean, sorry, not 4, 0, because x is 0. 0, so we get A again. How does that make sense? We'll look at the alphabet. A, B, C, D, E, F, G, H, I, J, K, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay. Basically it's saying, you know, whatever the character is, and then we're going to increase it by x. So the first character is A because it starts at A. And we're going to increase it by x. X is 0. So 0 plus 0 is 0. So we stay here. What is that character? The character is A. So we just add it to our string. Now we're going to add x by 4. So we first take our string here, and then we add an empty string. And then, okay, well, what's our character? At C, was C is 0, right? So what's our first characters? First character is A, and then we're going to increase it by 4. So 1, 2, 3, 4, that's going to be E. So we add an E here. And then we're going to increase this by 8. So basically we're going to go E, and then we're going to add 4 again. So 1, 2, 3, 4 is I. And then 1, 2, 3, 4 is M. So A, E, I, M. 1, 2, 3, 4, Q. A, E, I, M, Q. So the answer is B. Yup. Easy. 34. From 1 through H. H is 3, so it's going to run 3 times. T times equals M. So we're going to have 1 times M, which is 4. This is the first one, second one, third one. So what's 4 to the third power? That's just 64, 34C. Okay, that one was easy. Oh, maybe I just don't have much energy to like really explain what I'm doing. 2 stacks. So stacks, I'm just going to write them bottom up because stacks are LIFO. Last one in is the first one out. So we're going to look, we start at 12, and we increase it by 6, so multiples of 6. We're going to add the 1s digit to our stack and the 10s digit to the down stack. But line 35 says, what do we want? We want up dot peak. So we want to take a peek at the first one in up. So who cares what down is right now? So we're going to keep adding 6 to 12 up until we reach 48. And 48 is a multiple of 6, so we're going to stop at 48, and the answer is just going to be 8 because 48 mod 8 is 8, and that's going to be at the very top of a stack over here. Now we look at here, down.push, up.pop. We're going to do this 4 times. So we had 48, and then we had 42, and then we had 36, and then we had 30, and then, you know, this is 24 and so forth, right? So we're going to add to down, sorry, this is up, this is down. You know, we don't really care what these numbers are. So we're going to add it to down, up.pop. So we're going to do this 4 times. So don't care about this one, this one, this one, this one. So, sorry, 1, 2, 3, 4. So we stopped at 30, right? But, you know, we're not really pushing 30 into the stack. We're actually pushing 30 mod 10, which is 0. So what's the top of the stack? 0. So the answer is A for 36. Look at 37. What's the output of line 37? It's going to run 5 times, and we're going to pop down 5 times. So remember we added 4 to down, which was the numbers at the top of the up stack. So we don't really care about those numbers. So, 1, 2, 3, 4. Then we're going to pop the top number from the down stack that was originally there. And then we're going to push it to U. So all we really want to know is what was the last number on that down stack originally. Well, the last number is just going to be 48 divided by 10, which is 4.8, but we don't care about the decimal, so the answer is 4. So 37 is C. 38, oh wow, look, we're almost done. 38 is matrix, so it's a 2-dimensional matrix. So remember RC cola when you do these double nested loops. In here, this is your row and this is your column, right? So X is your row, Y is your column, so looking good here. So we start at 1, right here, and we end at the length minus 1. So we would end here then, because if it was just box X dot length, we'd go through the very last row too. But because of that minus 1, we don't want to include that last row. Now let's look at here, Y1, so we're going to start at 1, and then same thing. We're going to go through the entire length of the row, minus 1. So we're going to stop right here. And we just want the intersection of that. So these guys, basically. And then it says counter plus whatever the element is inside. So 7 plus 5 plus 3 is 15. And then 9 plus 1 is 10, so 25. The answer is A. This one is postfix. Look at it, just easy 6-point staring right into your face, basically. Postfix is a left-right root. If you were in UIL calculators, you'd know by now that, using the reverse Polish notation in your calculator is a very efficient way of cracking through all the number crunchers or the computations. So you'd probably very easily be able to do this, but basically you want to group up the operands and the operator right next to 2 of the operands. So 6 and 5 here. And then this is going to equate to 30, right? Because 6 times 5 is 30. And then you're going to do 7, 30, and this plus sign. So 7 plus 30 is 37. And then 8 minus 37, which is negative 29. Then you're going to do 9 plus negative 29, which is negative 20. And then you're going to do 10 minus negative 20, which is 30. So the answer is 30. Now this last one, binary search tree, very easy. We're going to start from A, right? So let's push A into the tree. So our parent node is going to be A. Now whatever is less than A goes left, and whatever comes after A goes right. But A is the first number, the first letter in the alphabet. So we're always gonna be going to the right. So U is greater than A. So U goes to the right. S is S greater than U. Q, R, S, T, U. So S is less than U. So it's gonna go to the left. T, Q, R, S, T. So T is less than U. And then T is greater than S. So it's gonna go to the right. I is less than U and S. So I goes to the left of S. And then N. N is less than S, but greater than I. So this is how your tree should look like. It's asking you how many leaves. Leaves means how many nodes don't have any children. And the only nodes are N and T. So the answer is 2. U is not a leaf because it has one child. So there we go. yeah, this exam was really easy, really straightforward. Don't know how much time I took to get through all this. Sorry, I sound very monotone. It's actually kind of expecting for me to be more funny, maybe throw out some Gen Z terms like Scooby Toilet Riz or something like that, but I guess not. But basically, I just wanted to explain and show you guys that it's very easy to get points on this test. Just, first of all, can you even read the question? Like, do you understand the syntax? Um, Once you understand the syntax, okay, what does the question want me to do? Once you can understand that, then you can understand, then you can answer the problem. And it's just like a math problem, pretty much. So, yeah, first understand the syntax, and then just think to yourself, what does it want me to do? Oh, it wants me to do this. Okay, so then do it, You don't got to go through each one. Like, you hear this for loop. You don't have to do, like, okay, 12. Now we got to add 6. Okay, 18, and then 18, and then this. It's like, no, like, just really care about what's important and what's not important. And then look at the answer choices. When we're doing strings, you don't have to go through the entire for loop. At some point, these strings are going to differ, right? And so you kind of, keep going until you found the only one with the right matching so far. And then you don't have to do the rest of the problem. You just like skip, like you just keep going. If that makes any sense. Sometimes the strategy could be to do the first the first page, because they're generally the easiest, and then the last page, because the last page is also very easy as well. The middle pages are the ones with a little bit more Java knowledge. Surprised for a state test how easy this is, or this was. Just kind of hoping for it to be a little harder, because I'm not a Java expert. Haven't done Java since high school. I'm like a year out of college already. Don't do Java in my software engineering job, so I'm kind of surprised how not difficult this was to do. But the programming problems in UIL are actually very difficult. I cannot do them all. But yeah, hopefully this helped you. Oh yeah, and also like look at these explanations. The explanations are short, and they kind of tell you, like what the problem they were asking you to do. And so because these explanations are short, they're not really asking you to do much. So just really understand the problem, and then from there you can answer the problem and get the answer. Easy 6 points. Okay, I'm gonna end the video. Please comment. I get more value from your comments and I guess likes on a post. I feel like when I like on a video, it's because I want to save the video into my liked videos. But with comments, I really get to know if people like the video, if they don't like the video, what I can do to improve. Again, I'm doing this because someone commented like a day or two ago I should do a model revision of this, and a lot of people had asked me over the years to continue making these videos. Don't know if I'm gonna be consistent with that, but I just wanted to do this video because I took the exam yesterday and I did all the problems. I thought I missed one, I didn't, so I was very surprised. So I just wanted to make a video just to show you guys how easy it is. I know you guys have more competitions coming up, so maybe this video gives you more confidence to try and qualify to go to regionals, hopefully the state. There's a lot more nuance to these problems, like for example this right shift problem. Because these were integers, it's easy to do the division method, right? But you could get to a point where maybe you're doing bytes and you do left shift and you multiply the number by powers of 2, but then you get to overflow and you're not going to get to a number that's greater than a byte. So it's better in that case to convert the number to binary than to get the answer wrong. I don't know. Maybe I will go over more tests, and then looking at the explanations, you kind of see what to do in certain situations. Yeah, these tests aren't hard, guys. So if you want me to explain more, just let me know. Probably did a really bad job at explaining. Sorry about that. Yeah.